Hello, everyone, and welcome to another episode of Learn with Jason. Today on the show, we are going to be tackling something that I think a lot of developers find pretty intimidating, which is the idea of building a game engine. So if you've never done that before and you're feeling like maybe that's out of your reach, today's your lucky day because we're going to figure out how that works. I've never seen it myself, so I'm very excited to dive into this. And to teach us all about it, we're bringing in Will King. Will, how you doing?
I'm doing pretty good, Jason. Doing good. You can kind of see right here. I got in a battle with my 1-year-old and he won. So we're doing all right.
Always a good time. Always a good time. It's probably good that you let him win.
Always. Yeah. No. Definitely let the kiddos win. They can learn when they're older. They'll hit a minimum age threshold and they'll remember that daddy is still stronger than them. At least for a short period of time.
Right. Yeah, you definitely gotta you give them a false sense of security, lull them into that confidence, and then you establish dominance until they outgrow you.
Oh,
so
yeah,
at least that's how it was in my family. Is that not how it is in every?
Yeah. No, I mean, and you should establish dominance for an embarrassingly long amount of time to where your kids feel like, well, let's just give this one to dad. Like that's how I see it going.
Good. Okay, so outside of the parenting advice, for folks who don't know you, can you tell us a little bit about who you are, what you do?
Yes. Okay. So my name's Will King. I am a dad of 3. I've got a lovely wife. Her name's Allie. If any of you here know me, you know that Allie's favorite pastime is trolling me on Twitter. So like if you follow me on Twitter, X, whatever y'all call it, I have a beautiful wife with a hilarious sense of humor, and her favorite way to use it is to troll me. So follow me over there. Because I just talk about dev stuff. I'm a design engineer. I work at Crunchy Data. We are like a managed Postgres service. But I'm really just, as you'll kind of find out as we talk about this, anything related to products, digital design. It's just, I just love it all. So
Nice. Very cool. So I want to talk a little bit today about the idea of a game engine. Because I guess first and foremost, because that's what we said we were going to talk about, but also because I think a game engine is one of those things that on its face kind of feels like reinventing the wheel a little bit. There's a lot of tooling out there. There are a lot of platforms out there that'll kind of give you a game engine out of the box. So
right.
What inspired you to sort of take this on in the first place and learn how this works?
All right. So my first piece of advice to anyone listening is don't build a game engine on your own. If your goal is to actually build a game and sell it to that's your business. So like if you want to build a game and make money off of it, this is not the path to doing that. But it is an incredible path if you're not sure what project to take on to like grow and learn in like very wide varieties of like facets. So the reason that I wanted to take this on was I had recently started streaming, and there's just like you want to kind of like, I'm a design engineer. I love design. I've got a background in like industrial design, but now I've been like coding for like 7 or so years. So like, what is a project that kind of spans all of those very wide variety of skill sets? Game engine, because one, you've got to obviously be able to like develop the code to build it. There's also like graphics and rendering. There's also this like new facet of stuff that I'm not as familiar with that I wanted to learn, which was like being able to create story, like story arcs, characters, make you like be able to like emotionally connect with some kind of story. Like I think that is like extremely valuable these days, because like one thing that is very hard is like distribution and connecting with people with your product. And the way that happens is by like, one, you can have like obviously the best product that there ever was and people want to use it no matter what. But like a way to like reinforce that is by having a brand or like a story that people care about. So I was like, well, I want to learn how to do that. A game felt like a really fun way to practice that skill set. So
yeah. Okay.
why game engine from scratch? because I wanted to take on an ambitious project to learn like a whole lot of new skills.
And I love this. Like for me, the pursuing something for the sake of the journey of learning it, right, is one of the more fulfilling things that I've found in my career is, really just like tuck into something that's really hard, not because I have a specific, like, I want to deliver, in your case, a game, but because the process of going through all of this is going to give me so many advantages down the road, right? I think that really is like, I don't know. I really like that as a general approach, and it's driven a lot of the ways that I build, a lot of the projects that I make. I don't have a purpose for them. I was just like, that kind of seems like it'd be fun to figure that puzzle out, and off we go, right?
Yeah, 100%. I always tell people that like I owe my entire career to these ambitious projects
Mm,
because if I had not done any of them, and I've got like a giant list of them of
sure.
ambitious projects that I took on that I had like absolutely zero reason before starting them to like think that I could do it. Like I've
Right.
got no special skill set, I've got no like competitive advantage, but I just like decided to do something, buckled down, and like beat my head against a wall sometimes until I figured it out. And like I can name at least 3 of my mini jobs that I got specifically because of something that had nothing to do with my previous like work experience.
Right. You took on something gnarly and people noticed it, and that
Yep.
was enough. I love it.
100%.
I love it. So, okay, let's talk about game engines in the abstract for a second. So,
Perfect.
when we have a game, there's clearly a lot going on under the hood, but I don't know that I have sort of like the buckets of what's happening when I'm thinking about a specific game. So in my
Right.
head, everything is like a very specific and challenging thing. Like I'm thinking about, I've got a character, and so there's something making that character animate and move and all that stuff. There's actually controlling it. There's maps. There's actions, attacks and jumps, and you've got like collision detection, whether or not you've run into a trap or an enemy projectile or whatever it is that you do in the
Right.
games. All of that to me feels like kind of way outside of anything I've ever done before, and for that reason, it feels pretty intimidating to even I'm looking at a blank page. Where do you even start? Like, what are the big buckets?
Same, like like that is exactly my experience when I started this was, and that's why I wanted to do it. Cuz for this project I was like specifically testing like how much can I do with AI assisting me?
Hmm.
Not AI writing the code. I specifically picked a language like I'm to write my game engine to where not because I knew AI wouldn't be as helpful, but like I've been interested in this language. It's a very new language, and like
Hmm.
AI is not going to be able to write the code, but AI can help me think, help me research. So I did a lot of that.
It
So
kind of
like
help you get the concepts without doing it for you.
exactly. The way that I've begun leveraging it in my day to day is exactly that. Is like how
Hmm.
what can this help me learn the language of? Like if I'm learning something new, give me like the language that this speaks. Like
Hmm.
what makes developers really good at solving problems, Googling, researching, is because you know all of the terminology. When you enter something new, one of the hardest parts to getting started fast is like knowing the terminology and why something is like framed that way. So like your question, what was your first question to me when you're thinking about like, well, how do I get started on a game engine? Your question was like, what are the buckets? Like, what
Right.
is this even like? How do we even define like the
Yeah. What
system
are
that we're trying to build?
the core
Exactly.
parts of a game?
Yep. So the way I will say I've not finished building a game engine. So like we'll share like the very naive view of like what I would
Sure.
consider buckets in a game engine, which is you've got your game loop. Your game loop is a closed system that is constantly looping at like a what people call your FPS, your frames per second, and
Got
that
it.
is what allows you to render graphics at a consistent speed. And your game loop consists of two sub loops. One is your update loop, and your update loop is what says, okay, like what has happened since the last loop that we've run, and let's mutate our game state based on those updates.
Okay.
And that is the only thing it does. It is responsible for taking in events, updating game state based on those events and like the rules you've defined in your game. And then the render loop is just a like pure function of give me the game state and I will render that to a screen. So
Okay.
I think what makes it a little easier is like once you kind of get in there, what you realize is like everything is like very isolated, split off, like subgroups where like you're not
Sure.
really thinking, you're not really the way you phrased it when you started was like, oh man, like you've got this and you've got your collision detection and you've got like all like it's when you get in there, everything is not like all mashed together. You've got
So
you've
you're
got a bunch
not
of like
like
independent subsystems.
okay. So it's
And
not
their
like
job
one
is just
giant
to
function where I have like, okay, if character and enemies are like some giant coordinate matrix, and you know, like I imagine that is sort of what's happening, but like
right. But
in
you're not
more
when you're
control,
writing
you
it,
don't have
you're
to like
not
think about it
necessarily
all.
thinking about that. Right. Like
I
you're
got
not
you.
holding the entire system in your head. You're thinking
Got it.
in very similar to most programming. Like once you get down to like the atomic ideas,
Mhm.
you've narrowed the inputs and outputs that you're expecting.
Gotcha.
So
Cool. Okay. So so you mentioned that you built your game engine using a tool or a language that was new. Did you say what it was?
it's called Gleam.
Okay.
If you go to gleam.run for any of you interested, it's a functional programming language that is like very it's like based off of like I wouldn't say it's fully based off of it, but like very influenced by Elm, which had its heyday early on in my career that I learned. But
Mm-hmm.
it's a functional programming language, very kind of based off like OCaml style syntax, but just a little updated. So you get your type safe functions, like everything's strongly typed, statically typed. You get immutable data structures from the jump. Um, and then Gleam, what's interesting and reason why I picked Gleam was when you're making a game engine from scratch for a game that's built in the browser, you've got to be able to like render in the browser.
Sure.
So it's like, okay, well, like obviously that means JavaScript, but like I didn't want to just use TypeScript. Like the whole goal was to like learn something new. I
Gotcha.
already know TypeScript, a little boring. So like let's try leveling that up a little bit. So Gleam compiles to TypeScript,
Okay.
but what's interesting is Gleam also compiles to Erlang, the Erlang runtime on the back end. And
Okay.
so like what makes that really interesting for game engines is Erlang's really known for like its ability to accept a whole lot of connections. It'd be very efficient on like the server side. And then on the browser side, you have your JavaScript to do all your client stuff. So in a game engine, what you can do is you can have all of your game logic, your what's running the game
Mm-hmm.
on your client. And instead of having to write a completely different language for your backend, Gleam also compiles to a very efficient backend language for when you need to track and manage like state updates to your game. So like anytime there's like a save state, you can just send this off. So like let's say like suddenly your game gets extremely popular and you have tons and tons of people on your game at the same time. Everyone's running their own version of the game in the browser. So like they're not worried about performance issues because
Right.
it's just them. And when you go to send off your requests to the backend, Erlang is extremely efficient at handling a ton of concurrent connections. Like that's the whole point of it. So like you're not going to have like you've got your optimized backend, your optimized
Sure.
front
Yeah.
end, and you've got a single language that you can write in the middle. Is the way that I've viewed approaching this project and why I picked Gleam.
Okay. I'm with you. Cool. Very cool. So do so we're not going to do Gleam today. Mainly
No.
because nobody wants to watch me get my first steps with any language. Involves too much cursing for a live stream.
Oh yeah. Oh, that would just be ridiculous. And like nobody would. We want people to learn as much as they can as well watching, and so like let's pick something familiar to get the concepts.
Yeah. So we're gonna dive in using JavaScript and TypeScript. And so is there anything like high level? Is there anything else that we should run through before we start getting hands on keyboard? Like, are there questions I should have asked that I didn't?
That is a very interesting question. I think the only I wouldn't say there's necessarily like any questions before jumping into the code. I think you kind of covered like as much as you can. Like this is one of those very very specific cases where like you really do have to like uncover it as you go because
Okay.
of a couple reasons. One, like what kind of game are you making? Maybe that's a question. It's like, what kind of game are we
great
making?
question. Yeah.
You know,
Let's
like if we're making, you know, like a first person shooter style game
then
versus,
different
you know, like
requirements than if we're doing like a
platformer
Zelda
game or
like
like
a
a Zelda Link to the
turn-based.
Past, exactly, or like a
Yeah.
card style game, like
Oh yeah.
all of those are game engines. And if you're using, you know, one of the big guys, they have all of those abilities built into them. But when you're writing something from scratch, like you're writing it very fine-tuned to the exact type of game that you're trying to make. And
I
although like
understand.
high level concepts may be the same, like once you get into like the actual like updating and rendering portions,
Hmm.
like that's where everything's completely different. So
Got it. Okay.
that's
Very cool. So, okay,
yeah.
let's do this then. Let me cut over to this side here. I'm going to throw a banner up so people know what we're doing. And
Perfect.
I'm going to first and foremost direct everyone to your social media. You said you are an X user primarily, so let me throw that one up for everybody if you want to go give a follow. And this episode, like every episode, is being live captioned. You can find past and upcoming episodes of Learn with Jason over on the Code TV website. And, you know, maybe consider if you're enjoying this content, you can subscribe on YouTube, or you can even become a supporter on Code TV to get exclusive behind the scenes stuff, early access to new content, all sorts of good things. And if you want to get those captions, you can get those captions by going to lwj.dev/captions. Let me throw that link up on the screen for a moment. And that is being done today by our captioner, Vanessa. That's my email. We don't need that up on the screen. What's going on now? There we go. So yeah, this is Vanessa from White Code Captioning, taking down all these words that we're saying. If you need that, let me put a banner up on the screen for a moment. There you go. You'll be able to get to that. And here is the link as well on the screen. So with that being said, Will,
Yes.
if I want to get started, what is the first thing that I should do?
All right. So the first thing that I would recommend doing is just being able to like get a canvas up and going and have like a game loop running.
Okay.
Um,
And is there like a specific framework or tool or like library that we're going to use today?
there are not. So like I think we can just write this whole like we're just focused on getting the concepts I think today.
So we're going vanilla.
And we're gonna go vanilla because there's not
Okay.
there are lots of libraries, and usually once you're getting into like library realm with game engines, you're not writing a game engine
They're
anymore.
giving you
Like
the engine.
you're plug and like you're plug and playing. So we're gonna go from vanilla here.
Got it. I have a notification going off that I'm going to silence. Give me just a moment. Okay, here we go. And all right, so we're going to use V. Let me get a new project rockin'. Come over on this side, and I don't think I have. There it is. So here's VS Code. Let me. Let's get to GitHub and Learn with Jason. We're going to npm create beat. And this is going to give us, well, let's see, build a game engine TS. And you want to keep it straight vanilla?
Let's do it. Yep.
Let's go. TypeScript. There we go. Let's get in there. I'm going to open this one up in its own window. We'll close this one down. And Get a init, npm install. And let's reload this window so that yeah, there we go. Now it's not dimmed. And just get it rocking. Let's take a look at the default here. So this is here's our starting point, which is a plain vanilla v TypeScript site with the kind of basic thing going on there. Let me make that
Yep.
a tad bigger for everybody. All right. So the place that I would start is I would come over here. I would create a README, and I would just call a shot here. So we're gonna say build a game engine in TypeScript, and we're gonna set up a to-do. So for me, what I would want to do is, I guess, first and foremost, decide what kind of game we're making.
Perfect.
And then it's not going to autocomplete those for me. Boo. Now that we've got that, this is where I kind of get lost. So we would need the main loop.
Right. So the first thing that I would do after that is set up canvas rendering and a loop to repaint your canvas. Is like the very first step is that I will start with, and then we can kind of take it from there.
And then once we've got that in place, I guess the rest of that will depend on what our game
type of game, right?
So let's start here.
If I may
you've
make
got ideas. You've got one. Let's do it. Let's let's play it safe.
Chat's gonna come out here with like make like a first person shooter in the browser in 30 minutes.
build GoldenEye.
We are gonna we are gonna build like a Legends of Zelda Link to the Past style game. So a top-down tile-based game. So you'll have, like your character will move around along the screen, that kind of thing.
Okay. All right. So that makes sense. I like those kinds of games. You kind of get the sort of like moving, one move is one square kind of thing. Like that makes sense.
100%. And
I hear you can build Doom with TypeScript. That is true. You can build Doom with TypeScript.
You can build a lot of stuff with TypeScript. There's like a lot of people building like really awesome stuff. There's a project called I'm gonna blank on it. I'll find it and then I'll send it in chat. But we'll move on for now. But there's somebody who built like an entire like turn-based strategy game in only TypeScript, and then went on to like sell it on, like, it turned out to like, and they've got like the whole code base open source, which was like a really, really awesome project to be able to like look at while I was trying to like learn as well. So I'll find that and make sure that we get that sent up.
Cool. All right. So we have decided what kind of game we're making. So now that we know that, we're going to set up canvas rendering. We're going to set up a loop to repaint the canvas, and then the things that so just to kind of do like basic idea capture here, the things that immediately come to mind is we need like characters, we need movement, we need collision detection, we would need like start, restart kind of capability so that if you like die you can start a new game sort of thing. Which I guess we also need death and damage.
It comes to us all.
And then what else? What else do we need?
What you will also need is you'll need like a decision on like what size of tiles that you're going to make.
Like map tiles.
Right, map tiles. You'll need like aspect ratio, like what is your like width and height of your like tile map gonna be. There are other things that you'll need, I guess, with this one, which you've kind of captured under like movement, and you'll need like a way to like attack, like actions would be one. And those all fall under this like concept of your like event messaging system.
Okay, so this would be like set up event
So
messaging.
we'll need, yes, I'd say like the next thing after loop to repaint the canvas is like
Mhm.
what we'll want to do after that is like, okay, now that we're rendering like a basic canvas in a loop, like let's go ahead and actually like decide on the size and render our like map, our grid of like what each map would be. Now this is what's interesting is like when you think about a map in a game, like it's the entire world. So what we're actually talking about rendering is like your camera, your viewport, if you think about it.
Mhm.
So like your camera is like what is currently viewable in
Right,
what
so
might be
there's
a much larger
everywhere you
world.
could go, and then there's
Correct.
where we are.
Exactly.
Got you. Yeah, that makes sense. Okay.
So yeah. And then once we've kind of got um, a map to render, what we can render after that is a character um, on the map somewhere. And then after we're rendering a character somewhere on the map, what we can do is we can then set up our event messaging to tell that character what we want it to do.
Okay. All right, so this feels like a good starting point. We'll probably come
Yes,
up with more
agreed.
along the way, but let's start here, and I assume I'm going to set that up in my main TS here.
Mm-hmm.
And then how do you want me to start with this? Do you want me to just blow this away and go empty, or do you want me to
So
keep some of it?
you can blow it all away completely from scratch, and that is
All
how we'll
right.
get started.
So let me delete some of these files we don't need anymore. And this, that'll be empty. This is fine. And then we've got our index here. All right.
Perfect.
And that will leave us with a blank screen. But the game is, or the app is still running. So as we update things, we'll be able to keep it rocking. So
Absolutely.
good. So first things first.
First things first, a blank file. What you will need, what we are going to do since we're doing it in the browser, is you've got to pick like a rendering context. So that means there are two choices generally with the browser. You can do like a WebGL 3D canvas, or you can do like a 2D canvas. We picked
Top down
specifically,
is 2D, right?
Right. So we're gonna pick a 2D canvas, which just means. Go ahead.
Do you want me to put this in as like a canvas element here, or do we
You
want to
could
like
you could do
generate
that.
it and drop it in?
I generally will just generate it out of the TS file so that I just
Got it.
you can either put it in the document and like go fetch it with, find by ID, or you can just make it and you already have like your reference to it there.
So if I
Perfect.
make it, do I need to do in a canvas? Do you have to use a different? I feel like there's one where you have to do a different type of create element to get it to work. Is that canvas?
This
or
is not
SVG?
it. That works.
Okay.
SVG is
Okay.
the one. It's like NS element, I believe.
That's right. That's right.
If my old memory from having to do that remember is good.
Yeah,
Perfect.
I was doing something a while ago and got absolutely cooked. Like lost like an hour trying to figure that out.
Oh goodness. Yeah, those are always fun. The next thing that we'd probably want to do, I would think, would be like a width and a height. So we have something that shows on the screen.
And so that we can just set straight up, and we're in. Is this set attribute, or do you just go straight on?
It's just straight on width and height.
And did you have a preference for this?
No, this is going to change in our like next step. So you can just pick something so that we have something that shows up on the screen.
All right, we'll just make it 800 by 800. Give ourselves a little square.
We'll append that to our document.
Okay, so then we need to get our app, which was document get element by ID, and that was app. And then I will app.append child, and we'll drop our canvas in there.
Yep.
And theoretically speaking, that means that we now have a canvas on here. There it is.
Nice.
Zoom out a little bit, actually. Oh, no, that's not it. Zoom in the console. We'll zoom out here so that we have a reasonable sized canvas. Okay. Okay, so we got a canvas.
Perfect. All right. And then the next thing that we'll need is we will need some sort of looping mechanism to like paint something to the browser. So what would you expect?
So what I would probably do is I would create like a function called render, and then I would probably like use request animation frame to recursively call it.
Yep. Nailed it in
Okay.
one. That is exactly what I would use as well. I looked into, like there's like set interval or like set timeout as options, or like for loops, that kind of stuff. But request animation frame is good for like two main reasons. One, it is based on like when the browser would like to be updated, which is always nice. And then two, a nice built-in feature is like games are expensive from a like a resource perspective. It's very nice that if you change your frame, like your tab in your browser, that your game does not continue to consume all of those resources. So when you change tabs, your request animation frame pauses for you and doesn't continue looping in the background, therefore like bogging somebody's computer down.
Okay. So right now we're just kind of doing nothing, but we're actually running a game loop.
That is correct.
Well, not yet. I'm not saving yet, but
and what I would actually do there is you can just pass. I mean, I guess you could do it that way. Yeah, let's just do it that way. That sounds fun. Never mind. Oh, interesting. We'll see if this works, and then we'll keep going. So
this
inside,
is my favorite way to do it.
Inside of your render,
you just did something that's gonna break, but let's watch.
Let's find out. All right. So inside of your render, what we want to do is we want to just like actually like paint something, just to get something on the screen. So what we need to do when messing with like painting on 2D is you use a get context, and that's where you.
And I should get the context outside, right? Or do you want to access it each time?
You can go ahead and get it outside. That's probably the more performant thing. So we're not fetching it on every single loop.
That's not it. What is it? Get 2D?
Nope. Nope. That's it. It's get context.
It is get context, and
then inside the argument, you pass 2D.
There it is. Okay.
Perfect.
All right. So now I've got a context.
Now you've got a context, and what we will usually want to do here is we want to set. The first thing that we want to set is like a fill style. So fill style tells us like what color the next shape that we're painting is going to be.
Okay.
So you can choose whatever color you want. And then after that, what you can do is just do, if earlier on, you could just say, if there's no context, just return and bail.
All right, so we'll just give ourselves that immediate bailout there.
And then what we want to do now is use context.fill rect, rectangle, but rect. And there are 4 arguments that go, well, there you go. So your X and your Y, which is like where your rectangle starts in the top left corner, and then how wide and how tall that you want the rectangle to be.
So what we want to happen here, assuming we did this right, is it is going to put a red square that is 100 pixel square up in the top left of our canvas.
Exactly.
Save.
Perfect.
There it is. Look at us go. Okay. But this is happening now every frame, which I believe browsers are running around 60 frames per second, as long as you're doing something that fits within their performance parameters. Is that correct?
That is actually what I was going to do for our next step. In just a second. But let's just go ahead and do that now, because that's an important thing to actually for us to be able to talk about. One thing that we want to do is inside of your request animation frame argument, let's actually use the timestamp that they're giving us.
use the timestamp, and that is
So
provided
the
here, right?
the very first argument that they're sending is like the current time of like when this request animation frame is run. And so this variable is like extremely important for a game loop, because the whole way that our game loop timing works is by measuring delta of time from like when did the last update run, and like what time is it now, like what's that change in time, so that we can update our game based on how much time has elapsed.
Got it.
So
And so for anybody who's never heard the word delta before, because I know this is one that caught me, if you start at 0 and then the next time you run the function you're at 100, the delta is 100. And then the next time you run the function you're at 150, so your starting value was 100, you're at 150, your delta is 50, right? So delta is
Exactly.
just the difference between two numbers.
Perfect. That is exactly correct. So what we can start doing here is, if you want to create a new variable outside a global like variable outside of our render function, this is going to be the beginning of our game state. So you can call it whatever you want it to be.
And is this mutable, I assume?
It doesn't have to be. I mean, it is, because it'll be an object, and
Oh, I got you.
objects
Okay.
are,
And so this is going to be our state.
correct. And let's give this a property of previous time. And we can give it an initial value of performance.now, which is basically
Performance.now.
what timestamp is. Like it's basically like calling performance.now inside of each loop, but it's just given to you as an argument. And so now
then we would want state.previous time to equal timestamp on each update. Is that right?
Maybe. We will at some point, yes. But for right now,
I'm
what
helping.
you are helping. You're doing great. Because like, yes, what we want to do is like each loop, as we move on to the next one, we want to track what the current one was. But what we can do now is we can calculate our frame per second and just get an idea of like how fast the browser is rendering everything.
Yeah. Okay.
So let me get that pulled up. So frames per second is like timestamp. Our timestamp is in like milliseconds. So like what we want to do is basically get whatever our state.previous time, our like timestamp minus our previous time, is our delta, our change. So this is our like time since last update is what you could call it, delta.
Okay.
And then to get our FPS, you could console.log 1,000 divided by the delta, because 1,000, these numbers are all in milliseconds, and 1,000 is 1 second in milliseconds.
Got it. And then updating this will make sure that we're keeping.
Exactly.
Yeah, okay.
So now if we go to our console, you'll see just a number get printed, a ton of numbers getting printed. And
so
what you'll actually
120.
Right. So what you'll see is that you are probably actually rendering way faster, because browsers are like extremely performant and very awesome. So like the first thing that you have to be able to do is like you want to control how fast your game is rendering. You don't want that. You don't want that to be like some unknown, very variable number.
Because that could like cause, if the computer's memory bogs down, like your game actually slows down, and like projectiles would slow down. And then if the computer gains its memory back, everything speeds up, and that would suck as a playing experience.
Yeah, it would. And like if it's over 60 frames per second and you're not doing something to like control that, then like everything moves very fast. Like suddenly you're like your character that's like animation is like bouncing up and down is like looking like somebody who's just like had like 5 Cokes. Like my 2-year-old when their grandmother like let them have Coke for the first time. So what we want to do here is we want to create what is called a fixed delta time system. Which is basically just like we will leverage an accumulator and the time difference to be able to like render our updates in like fixed increments. So onto our state, what we'll want to add is an accumulator that starts at 0. Perfect. And then inside of our request animation frame, what we'll want to do now is take the game state accumulator and add onto it our delta every time it's looped, because sometimes that delta is a lot, sometimes it's a little. But our accumulator kind of lets us know what's like the total number of, like the total amount of time that we are like behind, that we need
Got
to
it.
like update for. So in some cases, what that means is like our accumulator, let's say it's at like 67 and our frames per second is 60, it will run
Mhm.
once. We will have 7 milliseconds left over. And so the next time it loops and say it's like 90, let's say it's like 113, those 7 leftover milliseconds added on to that give us 2 full frames that we needed to account for. So this allows us to like always make sure that like updates are happening, like you account for every single update no matter what the drift in like relative time is compared to like how long a render might take.
Okay.
So we have our accumulator. We've now you can go ahead, now that you have your accumulator, you can update your previous time. You've got that. We've console logged our frames per second. And then what we want, go ahead.
Yes. So we've got our frames per second, but as we're controlling, we probably want this to change to reflect what our accumulator is doing.
Yes, 100%.
Okay.
So the next thing that we want to do is we want to define like what our frames per second is in a constant. So we want 60 frames per second. So like in a constant somewhere, we want to like have what we're going to call our fixed delta time or frames per second, which is 1,000 milliseconds divided by 60. So
1,000
60
milliseconds divided by 60.
Right. This gives us like the actual amount of milliseconds that would like equal 60 frames happening within a second.
Right. That makes sense. Okay, I got you.
And then what we will do is we will make a while loop that basically says while our accumulator is greater than or equal to our frames per second, we want to loop through this.
Okay.
And so this will basically give us a chance to like make our updates as long as there are like expected frames to be running. And that is where we will have like event updates, et cetera, for telling people, like telling our characters what to do. And at the end of the while loop, we will have to update our accumulator so that it actually eventually goes away. So like you'll subtract from the accumulator your frames per second
on each while loop to knock it down.
Yep.
Okay.
Perfect.
Okay.
There we go.
So now we're running a game loop, and this game loop is theoretically running at 60 frames per second. And our 60 frames per second is giving us an opportunity to do our event loop here.
Yes.
Okay.
That is correct.
I'm with you. So that's cool. What I guess what's the next step? Because like mathematically, I understand what's happening, but I feel like it's a long way between a red square to Legend of Zelda.
You're correct. All right, so let's start. Let's do the next step that we're going to take is a little. It's less about our logic of our game, which we will get to next. But to be able to like add an active element to our game, we first have to have like a map for the active element to actually work on. So let's define how many like our tile grid. So how many rows, how many columns do we want in a map for our character to like inside of our camera viewport? Do we want them to move around? So that's like a high level constant that will define like how many tiles across and how many tiles down that we want our game to be.
And so if we stick with this 800, we could just do an 8x8 of 100 pixel tiles, which would just be 8 of these across, 8 of these down.
It could very well be. One thing, so like if we're starting to talk about games, one thing that's like interesting is like what is your like this is now where we're getting into these like other like disciplines. Like as you are making art for a game, what are like common art sizes? The beauty of a browser is like you can make it whatever the heck you wanted. You know, like
Oh
you really
yeah.
could do 100 pixel tiles. Um, or if you're like very influenced, say for instance, by like Link to the Past, and you want to have like reference material, or you want to use some like off the shelf
Right.
sprites. So a sprite is just like a fancy word for like your graphics um, for characters.
Hmm.
There are some like historical patterns for like what you use. So and historically the patterns existed because of like hardware limitations.
Hmm.
Um, and so like when you pick one, you can pick a style that you really like. So like a lot of the game is just like, how do you feel? Like what is
Right.
the art direction that you want to take it?
So if we're kind of in keeping with the Link thing, that's like 8-bit art, right?
I believe so. It depends how far you go. So there's 8-bit, 16-bit, 32-bit, 36-bit. Is that what it?
Okay.
8, 16, 32, 40, like all these kind of things like that, depending.
Yeah.
So like 64, and it also is like how much time do you want to spend? 60 if you're making pixel based art, 64 pixel tiles is a lot of work.
Yeah.
So like generally speaking, for like a hobby project, 16 pixels, 16 pixel tiles is like a pretty easy
Okay.
way to get started because you're you're not having to like paint a ton of detail into them.
Uh-huh.
And there is a whole lot of history and reference for like 16 pixel by 16 pixel tile art. So I
Yeah.
think that would be a good one. 32 is also a pretty good one. You get a little more detail in there if you want to spend the time to do it. And there's also
Sure.
plenty of reference for that too.
Okay. So we if we picked 16 as like our tile size,
Right.
then we would want to pick number of tiles across and down. Is there a number that you found to be sort of a good safe bet?
This one is like totally up to you. We're in the browser now, so like we can do whatever we want. You could pick a historical resolution if you wanted to, but I
And
think we
that's
could
what,
just
like
pick
1024
one
by
that sounds fun.
768, right?
Yeah, like something
Um,
like that. But you could theoretically just do like any number times your tile size to get
yeah. Okay. So
like a good
what
number
what
of
is
columns.
like 1024 divided by 16 is what? 64? So what, you know what? Why don't we just do that? Because I know that those are numbers that add up.
Hmm.
Um, oops. So we'll do map width and map height. And it's going to be 768, which is 48. So we're doing a classic size. And now we know what the width and height of our canvas should be. We know what our tile sizes are. So that'll give us 64 tiles across, 48 tiles tall.
Hmm.
All right. So what are we doing next?
So the next thing that we want to do is actually render said tiles. It might be good to just go ahead and pull the 64 and the 48 into their own constants as well as like columns and rows.
Oh,
Because
okay. I
that will
gotcha.
be
Yeah.
a value that we like regularly reference.
Got it. Let's do it. And then we can do columns and rows is going to be 48. All right.
Perfect. So now we know that like our canvas width and height should be the same as our like map width and height.
Okay. And so I want that to be map width. We want this to be map height.
Yep.
And down here, we would theoretically want to draw our tiles on in the loop, right?
Exactly. So now
Okay.
for our render, the way that we would think about our like render function is that we want to loop through each row and each column so
Mm-hmm.
that we have like an X and Y coordinate to those.
Okay.
And now that we have like our XY coordinate, we can say like, well, what exists in at this coordinate?
Okay. And so
So
to just set that up to make sure I understand. So I'm gonna set up a for loop through the columns, and then a nested for loop for the rows. And we're going to use the X and Y values as we count up to the maximum number to build out. Okay. So what is it? Is it let X in columns? Is it in or of? I never remember.
So this one might be of. I used just like a for real old school for loop. Let's see if of works, because there are better for loops now.
Damn it! What are you? We might have to just try this. Let Y of rows, and then we will be able to do. Okay, so to figure out our X and Y value, because for each of these, we're going to want to context fill rect, and we're going to want to use not, and this isn't our actual X value. This is more of our like index.
This is like our coordinate. Yeah. This is like what tile are we rendering? But once we actually like, when we think about it as like a size, each tile is like its coordinate times its tile width and height.
Right.
And since our tile width and height are the exact same, then we know our actual like XY would be, tile column number times tile width.
Right. Times. Wait, did we say tile size? Tile size is what I said.
Yep. And I think you'll have to, since we're using numbers, I think we'll have to use just like a traditional for loop. I think like the of and
Does
the
that really not work?
I think the of and the in syntaxes are like for arrays and objects. Maybe in works.
Boo. Okay, that sucks. Okay, that's fine. Fine. Let's go 0. This is why everybody uses I. Is less than, because we want less than, not less than or equal to columns, and then we want tile call number plus plus.
I think you actually do want equals to, but we'll find out.
Okay.
No, equals is good. Equals is good. Let's start there. Let's do not for now.
Let's do this, and then I'm gonna take you, drop you over there, and switch this out to rows. No, whole thing. There we go. So now we've got our tile call number times tile size is our X value. We've got our row number is our Y value. And then we're going to use tile size twice.
Absolutely.
Okay, so theoretically speaking, what will happen?
Now, you'll want to... So we will probably not want red for our underlying color. So if you want to use like X value, that seems a little more like, let's do like a sand color. You can use one that is BD. It's a hex, so it'd start with the pound. We'll get BD 1434.
Okay.
And that's not the right color. Sorry. That's I gave you the color of our next step. So try this one instead. F5E.
F5B.
F5E as an egg.
E.
1. E as an egg, 2. This is taking me back to my IT help desk days. I used to work at an IT help desk in college, and people, like, one of the biggest things you did was reset a password. And so like you'd have to like do the slow, let me go through like the E as an egg, A as an alpha, all sorts of fun. All right. So now we have a map. And we have our map rendering in 60 frames per second.
Okay, so here's our map. Our map is rendering, and we have, we are doing stuff. So if I was, can't remember where this is. I'm not going to worry about it. So we would, if we put a stroke style on this, we could see our individual tiles, but I'm not going to stress about it.
Yeah.
Actually, why don't we do that? Because
why don't we? That'd be great. Yeah. So if you do, you could do stroke style and just set it to.
I was thinking maybe like white, so we just get like a really simple one.
A good way to break it up.
And then we need a stroke width.
So, well, no, what you'll do next is you actually have to draw a like stroke rectangle in Canvas. So if you go down to where you're drawing a fill rect, then you'll actually also want to draw a stroke rect with the same values.
Ah, there we go. Everybody can see that, I hope.
Perfect.
See let me, if I zoom way in, you can see it. And then when I zoom out, this is our 64 by 48 grid.
And then if you want to make it extra interesting for people, like just like a little extra piece of info, copy stroke rect and paste it before fill rect real quick, because I want to show something. This is like something that you don't necessarily think about too much before you get started, but the way that go ahead and did you save that?
I did, and because this, wait, is it supposed to do something different?
It is normally. All right. Interesting.
Well, it did. So watch it. It becomes.
Oh, it comes a little thick. Oh, because they do.
Thicker,
Okay, so the
right?
way that's
They're,
okay.
like,
So yes.
overlapping.
Okay. Yeah. All right. So that's like when with Canvas, the order that you render your elements matters, because if you render whatever comes first is the bottom layer of your render stack. And so that becomes a very fun problem as you have more and more elements in your game and knowing which
Right.
things belong on top of other things. So fun thing to keep in mind for all of you out there. All right, so let's do something that is like actually more interactive.
Okay.
We're going to add our character. So what we can do here is, and what might be a little better for this, let's go just for temporary sake, let's cut our like columns and rows in half. Just for the sake of making them a little bigger on the screen. I think that will be. And then what we can do here next is you can that'll work. Let's just do it like that. Perfect. All right. And then in our state, what we are going to store now is like a new value in our like state object, which is like our character.
Got it. And is it like character position or?
It is. So what we are going to store is like, once again, very naive because we're just getting concepts here, but our character coordinates. And you can think of your coordinates as just an X and a Y.
Got it. So if we start our character up here, we would then probably want to check. So like if state.character, there's not an easy comparison for this. So it's going to be like, how dare you, at 0 equals tile call num. And we'll just copy this whole thing. Is this what you wanted me to do, or am I going rogue here?
You're going rogue, but you're nailing it. That's exactly, it's exactly the step.
Okay, so then what we would want to do is probably set like the context fill style is maybe a different color.
Correct. So now you can now you can do that other color. The
okay,
BD
remind me what it was.
All right, BD 1434.
Okay. Else, we're gonna set it in here instead.
Nailed it. Because that's also a fun thing. Fill style is global. So if you change it for like one element, not that is generally something you're running into with like games, because you're generally going to be rendering sprites instead of like rectangles and stuff. But it is an important thing to remember that it's a global variable. And if you change it and don't remember to change it back to something else, everything will be rendered that color. Perfect. And then
I see what's happening. We're in an older version of TypeScript. I'm gonna fix this properly so that it stops yelling at us. Okay.
Perfect. And then what you'll probably want to do is not even use an else for that other one, because like you're always going to be rendering a tile. So like even if your character is there on that tile, you still want to render the tile like the tile under it, because your character is not necessarily always going to be
like so
like a
you're
rectangle.
throwing a
You're
full
now wanting to think about your character as like a separate element in
placed on top.
on your canvas. Exactly.
Okay, so instead we would do something kind of like this.
Mm-hmm. Yep. You could
Oh
do that.
no, I did it wrong because it's the paint order, so we need to put it below.
Yeah. Yes, we will put this down at the very bottom
Got it.
just to make sure that we're
Bottom of
rendering
this
this. If it exists, it's
So-
getting rendered on top. Perfect. And then, so now we have a character, but your character does absolutely nothing. Like he just stays there where you told him to be, and he
Right.
doesn't go anywhere else. So now, like what
And
we
if
need next,
if we manually change that, so like if we
right,
go 2 rows
Perfect.
down or whatever,
Exactly.
our character's moving.
hmm
Okay.
Now we need a system. We need some kind of system to where we know how to update the state of our character in our loop. And
Right.
our
And
loop
so
is a closed system. There is no like passing outside variables into like the function per se.
Okay.
You know, so like what we need instead is a 2-layered system here.
okay.
So the first layer is we need what I would call our messaging queue. So it is something that is listening to global messages that are happening, that you are defining are like possible messages for your
Okay.
game to receive.
And does that live in our state or is it like a separate thing?
So this one lives outside of our state.
Okay.
So this is just like, this could be anything. So for example, the reason why this is global and can live outside of this, and it will just be an array that we'll pass things into. If you are moving your game from like a ready state to a paused state, that is like
Right.
that is not necessarily affecting the current state of like the game being played. That is
Fair.
like,
Yeah. Okay.
that
I
is
get
like
you.
the state of your game loop itself. So
Right.
you've got to be able to tell the difference between more global messages and also like messages that like should send something to your game,
Okay.
your game
I'm
state.
with you.
So you'll have your messaging queue, and then inside of your state, what you are referring to is your event queue, which is the same thing, which will just be like an array of events.
Okay.
And a message. So if we want to do a little TypeScript here, and define some fun types, to make life a little easier, you could have a type that is message, and your message could be a union of like different message types. One of those messages being that a player queues an event. So if you want to change interface,
maybe just talk me through this.
If you want to do so for a union type, you have to use like a specifically used types. So type message equals, and then you define like, then you can define like an object state inside of it. So we'll call this one type inside of it as like the argument, and give it like a name. The way I like to name things is like very influenced by time that I spent in Elm.
Okay.
And how their like messaging system works, which is like who is doing, like who's sending the message, what's the action that the person is doing, and what are they doing the action on. So player queue event. So it'd be like the player is queuing an event.
And then how do you like to split these up? So I've seen a few ways that people will do this, which is like you can do the snake case kind of thing. You can do like a split character like that. I've seen
I generally
dots.
do camel case, but you know, like whatever makes you
You know
happy.
what?
I don't have strong opinions about this kind of stuff, you know.
Sure. Okay, so we
and
got a
then
player queue event.
we have a player queue event, and what you need to know is like what type of event. Like, so it's a queue event, and it's just going to accept an event type, and an event type is like what is getting put into our event queue. And so like we could
Got it.
define
And so
another type that will like it will look very similar to our message type, but it's just called a game event type instead.
Okay. And that's going to be what this is.
Right, exactly.
So
so you could do type game event. And for instance, in this one, what we'd want to have happen is like we want it to move. Now this is
right.
not necessarily
does it operate on something?
I wouldn't say that this one necessarily does.
Okay.
You can just call this one player move or whatever, and then like the direction that you're trying to send our player.
And this would be like up, down.
Yup.
Right. Okay. And we'll maybe start there, and then this
Perfect.
then would be any valid game event.
Mm-hmm.
Okay.
And we won't worry about any other messages. If we have time, we can come back and look at like our browser pause and unpause, because that's just like a fun little feature that you have to account for. But we can just start here. So now what we need is a way to listen for those, like what do we want to send, like what are we listening to send these events, so we know that somebody's trying to tell the player to go like up, down, left, or right.
Got it. Okay. So we would add like a on key press or something.
Mm-hmm.
And are you you're not adding that in the render loop, right? That would be
nope. So these would be global. These would just be global listeners.
Okay. So
and this is how like now we're thinking of like a whole new system. So this is like our event messaging system, and then what we're kind of writing now would be like our like listener or like controller system, which is like where are our inputs coming from, and how do we set up all of our listeners to listen to our controller, in which case the keyboard is the controller here.
Okay, and it would be event, is it key? Is that the
Yep.
right one? Okay.
Sure is.
And I'm making an assumption that we want like some of these
it'll be like arrow up with capital, I think. It's like capital A.
Like that?
Yep.
Okay.
And then in this case, what we want to do is push that this event happened into our messaging queue using the type that we defined.
Push, and it was type player queue event, and event type is player move.
It'll be another object, which will be player move. And
oh, right. Yeah, that's correct. Yep, I was. And now that we have that, it's going to be direction and up.
Yep, and then we just duplicate that for every one of those directions that we want to go at. Also, that's always a fun one, is when you set up your events. This is what happened to me the first time that I was working through this. You set up your events and you forget that switch cases have to have the breaks. And then you press down and suddenly your character moves like 20 times and you're like, what's happening?
That's one of those like trauma memories. Like, when you have a response that you don't even know you're doing, but why did I not type a T on left either time? There we go. Up, down, left, right. And then we default we can just ignore because it'll do nothing. Or do we need to specifically ignore the default case?
Oh, you can just do it this way. This was perfect.
So this will build our event queue, but now we need to set up a loop
Now we need to process our event queue.
Right. Yep. And do we do that?
Or our messaging queue. Yes. So now we go down to our rendering loop that we've kind of started defining. And what this is starting to turn into is is less of just a render loop, and now we're getting into like our game loop and our render loop. Like our game loop is like the overarching what's going on, and then we have like our update portion and we have our render portion. So currently we're kind of mushing them all together, which is totally fine. And we're not going to worry. We're not going to worry about.
Probably want to pull these apart.
We probably do at some point.
Okay,
I don't think it's too big of a deal right now. So the first thing that we want to do is before doing any updates on our game state, including before any like changes to like our accumulator or anything, what we want to do is pull our high level messaging queue, and we want to apply those messages to our game state.
Okay.
And then make updates to like our actual game state. So what we'll do is like you'll want to pull all the messages out of the queue and store them into a variable, and then clear that messaging queue array, so that like we effectively have like taken the whole queue.
Got it. And can we do a straight copy like this, or do I need to like
So if you use splice and start with like 0 and use like the length of the current queue, then it just like pulls all of it and empties it at the same time, which is nice.
Nice. Okay. No, not that one. There we go.
Perfect.
All right.
And then what we will now do here is we can loop through each message and apply them, which is basically like, yep,
for each.
And then we have our message. Then like what you'll want to do is just over time, like you'll have a bunch of different types of messages, and you'll probably have some kind of giant switch statement that says, if it's this message, this is what you do with it.
That's that seems like a good call. Let's actually set that up properly, because it would very quickly outgrow the if statements. So we'll do it the right way right out of the gate. Keep our lives simpler in the future. So we do a case, player queue event, and that's going to do something, and then break. And then I can this. And so if it's a player queue event, we right now just want to add it to the state, right?
Exactly. We want to push it.
So
we want to push this
queue,
into our event queue.
And that would be event. No, that's not it. What am I doing? Message.event type. And I named this wrong, because it shouldn't be event type. It should be like event.
Yes.
Right?
You could. Yeah. It would just be like it's a full event.
Yeah. Because I'm like already confused by my own name. So I'm going to fix that now. Why are you mad? Not assignable to type never, because we need to do the thing up here that I was going to ignore, but fine. So we'll do each of these. All of these are number except for you, which is an array of numbers, and you are an array of game events. Okay, perfect. Now you'll stop yelling at me and I can continue with my life. Good. Okay. So now we are looping through our messages. If it is a player message, we're putting it into the current game state.
Exactly.
And
if it's like if it's a pause or something else, what this does by putting it up here is it allows us to, if an event has come in that should stop the game for any reason, we're doing it before we do any more state changings. Exactly. So now that we are done with that, what we will do is inside of our while loop. So our while loop right now is what we are thinking of as our update loop. The one where we're only doing these updates if it is currently in a like 60 frame per second state.
Mm-hmm.
And it's basically the exact same thing structurally, which is, pull all your events off of our state and empty it, and then loop through those events, because you definitely don't want events sticking around in state and getting run multiple times.
Okay, so we'll run this and then state.eventQueue.length Okay, and then we're going to events.forEach
Mm-hmm.
event, and inside here we will say switch on the event.type, and if it is a case of player move, then we want to, I think I know what we want to do in this case. And then
See, this is exactly what we were talking about when we started, which is if you think about all this whole thing of like, oh well, I need to like listen to key presses and I've got to like manage this whole state for a character moving around. Like now you've gotten down to like this, like you're processing, okay, the player pressed a button. I know it's a player move. I'm not thinking of all these crazy things in this whole like I'm just moving a player. Like I only have
yeah,
to care about like the exact event that I'm receiving, which is
I got you.
moving a player. This is the direction. Let's just like you're only worried about this like atomic action. And it like you said, you immediately were like, oh, I know what I should do here. And you've been like what,
Yeah.
writing like a game engine for like 45 minutes, you know?
Right. So so I want my new X and my new Y, right? And those are going to be what we set up, and then we would say so this is going to be kind of a gross if statement, right? Because we kind of have like an if
Mm-hmm.
like it okay, I already don't like what I'm doing here. So let's set these like this. And then I can say if event direction equals up, then I would want new y to equal math.min of 0 or state.character.1 minus 1, right? Am I doing that math right?
You are 100% doing that right. Why don't you explain why you use math.min for everybody?
Because I don't want my character to move off the map, right? So if we are at if we're right now we're at 0, and if I tried to move up, I am at the boundary of my map, so I don't want my character to be able to go any further up. And then the same general idea, when we get to the bottom, we need to check that it's not more than the number of tiles tall, which I guess I can do really quickly right here. And we'll say else if direction is down, then we are going to do math max. And what was my number of columns? Rows. And it would be a +1 this time. Okay, let's check that I'm doing this right, because before I write the rest of these. So now that I've got this set, we need to actually I just need to update the character, right?
What you'll do is you'll just make sure that the character on the state is updated with their new coordinates.
And do I do it right
that's all
here?
that's all you have to, yeah, you do it right here. You update, this is your update loop. And
Okay, so my
then
state
what this
character
allows
equals new X, new Y.
You might have a small bit of an issue because there's not a default there for our X.
You are correct. Let's go state.character 0 and state.character 1. That way we just initialize with where they already are. So now, in the thing, it's not doing anything. And it's not doing anything for reasons I don't understand. Do you see something that I did wrong?
All right.
Should I just start console logging things?
Go ahead and console.log, and then let's go ahead and
Oops.
No, that all looks good.
Okay, so all right, my listener's not working for some
Yeah,
reason.
let's look at our listeners to see if that's getting pushed into the queue.
Let's go messaging queue. Put this down at the bottom to make sure I'm actually doing it. No. Are you listening at all?
Try key instead of key press. Let's do key down.
Oh, there we go. Okay, so that was something horribly wrong, but let's see where. How did I get to 24 already?
I think you still want. Okay, interesting. Let's go to your down. Your down math.
My down math.
Because
whoa, that's what
we still don't
these
want
backwards.
Math. Yes,
because max, I always do that wrong.
Yeah.
However, let's go, everybody.
There we go.
That part's broken. That part works.
And
why didn't my rows work?
Maybe it's
oh, I'm getting one more. So it needs to be rows -1. And you
correct, because our coordinate system, technically the final row is 23 or whatever, but yeah.
Right, and now as I'm pressing down, I can't go any further. As I'm going up, I can't go any further. Excellent. Let's do the exact same thing, but for our left and our right. And oh my God, why can't I write left today? Jeez. This is columns, and this is our Y value, and these both X. Okay. Now we can move around.
And now we have our character that moves around our map.
Sick. And it can't escape out the bounds. Beautiful. Okay, so, I mean, this is, it's a pretty simple game, but we literally built a game. Like, I'm controlling a thing on my computer with key presses. That's exactly what I would have expected.
Yep. And you've also, I think what's interesting is that, you've done some very, not naive, but, important, but also, you said collision detection. And when you think of collision detection, you're just like, that sounds horrifying. But it was just
kind of what that was, right?
That's exactly what it was. You're collision detecting the edge of your map.
And you're basically saying my character cannot move into certain coordinates. So more advanced collision detection would just be defining areas within the tiles that are also not allowed.
That are also not allowed. And then all you're doing is at each, you're just rendering a tile. So the only thing you care about is what exists at the tile that I am currently trying to render, or in this case with the update, it's okay, I have a target tile. I have a tile that I'm trying to move towards. What exists on that only that tile. We don't care about the whole map. We don't care about the whole world. What's on that tile? Do I care about what's there? Is it going to restrict my movement? If yes, then we don't move.
Extremely cool. Okay.
Yeah.
So looking back at our README, because unfortunately we are a little short on time, but we got canvas rendering. Yep. We got a loop to repaint the canvas. We got our size and rendered the map. We got a character on the map. Whoa, whatever that was didn't work. Come on, buddy. And we set up an event messaging system. So we also got movement done. We didn't get actions. We got a basic kind of collision detection done. We didn't get to these. We did get to the map tiles. We did get to our aspect ratio. So, there's quite a bit going on in this game. So this is kind of the next step. Now, we don't have time to build this, but can we talk a little bit about how you start to think about this? I think enemy AI and attacks are probably two of the big things that I would think are those are the last unanswered questions for me.
So if we think about it, go ahead.
Hold on, before we do this, I'm getting a request for a part 2. You want to just want to do another one of these where we finish this out?
Let's do it. That'd be awesome. We can just keep working on the same game. Maybe for next time, I will design some like sprites, some actual tile sprites, and some actual like
Oh
character and enemy
yeah.
sprites. So we're not just working with boring rectangles. And
Be
we'll bring out some like actual like fun graphics for if we're gonna do a part 2.
That would be amazing. Yes, 100%. All right. Well, thank you for being down. I realize I just put you on the spot in like a live scenario. So,
Don't even worry about it. That's what it's
but
all about. Take on
right,
ambitious
just
projects, including
surprise.
a follow-up part 2 that we have to build.
All right, so we will come back, and in part 2 of this series, we are going to figure out actions. So we'll get some attacks in place, maybe something else. Get enemies on the board, and we will maybe figure out how we can handle like damage, life meters, things like that.
Yes, that would be awesome.
Excellent.
That'll be
Okay,
fun.
this was a blast. Thank you all so much for hanging out. Let's talk one more time about where you can find Will.
Sorry, I just saw somebody. I think is your name pronounced Steve on YouTube. He said game development taking longer than expected. Never heard of it, which is like the classic. Like always takes longer. Always takes longer.
Excellent. All right, so make sure you go and give Will a follow. You can find him on other social media as well. Make sure you go and check out the rest of what's going on Learn with Jason. We've got lots of good stuff coming up. We have, let's see, this is what we're doing today. We are going to be learning how to use LiveKit and Twilio with Dr. Sarah Guthels. We are going to be setting up SSH for SFTP with Ada Lunda, which is going to be super fun. I've never written any of the words in this title. I don't know what any of them mean in terms of how to build them. So that's going to be a fun one. Lots more coming up, things I haven't listed yet. If there's somebody you want to see on the show or something you want to learn, please do reach out to us. Let us know. You can hit us up at Code TV on Blue Sky. Have I shared this yet? I don't think I have. Let's do it. That's not how this works. You go to codetv.dev. Oh my God. Not very good at Blue Sky, apparently. But Christ, what is going on here? Whatever. We're gonna post the straight up DID, whatever that means. We're codetv.dev on Blue Sky. Go find us and send us messages and tell us what you want to see on the show. Will, any parting words for everybody before we wrap this one up?
The only parting words that I would like to share with everyone is I still don't know that much about game engines. I still have not built a full game engine, but I have learned a ton. There's been a lot of like fun and a lot of community that I've gotten to be a part of, this live stream, for example, and then just a ton of like great people who are just interested when you take on ambitious projects that you might be scared to do.
Mm-hmm.
Just go for it and like share and ask questions, and you'll be surprised. One thing that I always like to say is your project doesn't have to succeed to be successful. You know, like
if you learn
your project
you
could never finish it. You could never like find a lot of money from building something, but like you'll build community, you'll help others learn. You're going to help yourself learn. There's all sorts of benefits that come from just like getting out of your comfort zone and trying to build something you might have been scared to try to tackle in the first place.
And quite literally, even if the thing you learn never serves a purpose professionally, the practice of getting comfortable with being uncomfortable and wading into something new 1000% will serve you over and over throughout your career. Like I cannot recommend it highly enough.
100%.
Oh, also we have a Discord if you want to get into the Code TV Discord. Let me drop a link to it here, codetv.link/discord. We will and this episode, like every episode, has been live captioned. You can see everything that we've been talking about today right here. Thank you so much to Vanessa from White Coat Captioning for being here and being our live human transcriptioner today. Thank you all so much for that. And I think that's everything. There's probably stuff I forgot to say. If you enjoyed this, like, subscribe, do all the things that you want to do. Leave a comment because YouTube really likes that. And we will see you next time. Thanks, y'all.